The last question is one of my favorites because I really like the way this question is solved. The question is, you have a box, okay, whose surfaces are all made of mirrors. Okay. Now you have a point P here. So there's an incident ray here. It gets reflected from this mirror. It again from this mirror it gets reflected. It hits this mirror. From here it hits this mirror, and finally the ray passes through another point Q. So this is my object at P. The ray, it says, after all the reflections passes through a point Q. This mirror has been labeled as M1, this one has been labeled as M2, this has been labeled as M3, and this has been labeled as my M4. Okay. Now some of the distances are given like this. Distance of the point P from M1 is 20 centimeter. Distance of point P from M2 is 10 centimeter. Distance of point Q from M1 is 10 centimeter, and distance of point Q from M2 is 2.5 centimeter. Okay. Distance of M1 and M3, mirror M1 and M3 is it's 50 centimeter, and distance of M2 and M4 is, this distance is 30 centimeter. The ray reflects on the, or is incident on the mirror M3 at point R. So the question is, what is the distance of point R from M4? I need to find this distance. All these distances are given to me. So this is my question. This is a very interesting question. I sincerely request you to try this question on your own and give some time and try this question, maybe some 15 minutes, 20 minutes, and after that see the solution. Solution is as follows. It's very easy solution. So let's say these are my four mirrors, M1, M2, M3 and M4. Let's assume that this point has a coordinate of 0 by 0. You know that the distance of M1 and M3 is 50 centimeters. So my coordinate of this point will be 50, 0. Right? Distance of this point will be what? 0, 30. Right? Okay. This is the point P, or this is the object P. Now this mirror M2 will form a virtual image at this point, right? And for this mirror, this is the object, right? This mirror will form a image here, and which is the object for this mirror. Now what is the coordinate of the point P? The coordinates of the point P is the x coordinate will be what? 20, since it is at a distance of 20 centimeter from P1, and the y coordinate will be 10. Okay. Now what will be the coordinate of this image? It will be formed at the same x coordinate. So this is 20, and the distance, this perpendicular distance is same. So this point is minus 10. Okay. Now for this mirror, this is the object. So this mirror will form an image somewhere here. Okay. And for this mirror, this is the object. Okay. Now let's see what's the coordinate of this point. Let's call this point as x. From the mirror, this object or this object has a perpendicular distance of 30. So this distance will also be 30. So this x coordinate will be 50 plus 30, that is 80. And the y location will be, since these two will be in straight line or it will be parallel to this axis, the y coordinate remains same. So this is 80 minus 10. Okay. So I am done till this point. Now it was said that all the rays, the ray after reflection passes through point Q. Now if I use the principle of reversibility, if I say that my object was at this point, then it would have traced the same path, right? It would have traced the same path. So let's assume that this is my object. The coordinates of this point is what? It is, the x coordinate is 10 because it is at a distance of 10 from M1, and the y coordinate is 2.5. So its image will be formed here with an x coordinate of 10 and a y coordinate, with an x coordinate of minus 10, right? Because this distance is 10, so this distance is also 10, minus 10 comma 2.5. Okay. Now for this mirror, this is the object, right? For this mirror, this is the object, and this will form an image somewhere here, right? I'm just using principle of reversibility. This is my image. Now this distance is what? It's 27.5. So this distance will also be 27.5. So this x coordinate will remain same, minus 10, and the y coordinate will be 27.5 plus 30, that is 57.5. Okay. Right? Okay. Now you see that, what do you see? Now for this mirror, this is the object, and this gets reflected like this, right? I'm using principle of reversibility again. So for this mirror, this is the incident ray, this is the reflected ray. Now you see that this ray and this ray are the same rays. Okay, this is the same straight line. That means what? If I assume the coordinate of this point as 50 comma y, the slope which I get using this two should be equal to the slope of the line. What is the slope of the line? Using these 2 points, the slope can be written as y2 57.5 minus y1, that is plus 10, divided by minus 10 minus 80. Okay, that means 67.5 minus 90 is the slope. This should be the slope which I get from here, that is y plus 10 divided by minus 30. That means what? Y plus 10 is equal to 67.5 divided by 3. Sorry, I think I did some mistake here. Let's see. No, I think it's correct. This is equal to 22.5 or y is equal to 12.5. So my dr4 is equal to 50 comma 12.5. Okay, so this is my answer. Okay, so we are done with plane mirrors. Now we will move on to reflection in spherical mirrors.